Thank you, Ruth, and good afternoon, everyone. Equinor has an ambition to play a leading role in the energy transition. To deliver on this ambition, we have set the following aggressive targets in our climate roadmap. First, to have an upstream CO2 intensity below 8 kilos CO2 per barrel of oil equivalents produced by 2025. It's currently at 9, and industry average is around double that. Second is to have carbon neutral global operations and near zero methane emissions by 2030. Third, absolute CO2 emissions reductions in Norway of 40% by 2030. And last, to actually reach net zero emissions by 2050. This includes scope 1, 2, and 3, meaning also emissions from the use of our products. We have several levers and significant optionality to meet the net carbon target. And an important one is CCUS and hydrogen. The energy transition is an enormous challenge. Something similar has never been achieved before, ever. The building blocks needed are so huge that we cannot afford to pick or choose technologies or wait for the perfect one to present itself. We need all we can have from all technologies that can deliver emission cuts in a safe, timely, and cost-efficient way. In low carbon solutions, which I head up, we work to identify, mature, and develop hydrogen and CCS products. We are convinced that CCS and blue hydrogen are technologies that tick all of the three mentioned boxes: safety, time, and cost. This slide shows an overview of our main projects. We are engaged in activities ranging from open source CO2 transport and storage, Northern Lights, several pre-combustion or hydrogen projects, as well as traditional post-combustion CCS projects based on gas-fired power plant. I will come back to Northern Lights number later. From the rest of the portfolio, the two segments that we are most engaged in are power generation and heat. But we also have other initiatives ongoing. The ship you see in the middle is a bunker vessel for transporting hydrogen as liquid from the production site to, for instance, cruise ships. This project is based on green hydrogen planned to be developed at Mongstad on the west coast of Norway. We're also looking into industrial applications for hydrogen, for instance, as a reduction agent in steelmaking. This is a very interesting proposition where hydrogen can replace coal and make significant impact on reducing CO2 emissions. In addition, we are studying capturing organic CO2 from biomass power production and to add blue hydrogen to make synthetic clean liquids as a real physical alternative to offsetting emissions by buying quotas. Then let me move to Northern Lights. I have the honor to chair the board of the newly established Northern Light joint venture. I think you're familiar with the project, but there are some quick facts I like to share. The Northern Lights project is the partnership between Equinor, Shell, and Total, where CO2 will be shipped from industrial sites and injected for permanent storage several thousand meters below the ground in the North Sea. It is the world's first flexible CCS project where CO2 can be captured and stored at different locations. So basically, we can collect CO2 from all industrial sites with access to a port. The project is the key part of Norway's state-funded Longship or Longboat project. Academia and most policymakers now believe that CCS is a prerequisite to meet net zero ambitions. The reason is that not all industries can be electrified and not all can be net zero by fuel switching to hydrogen. Some industries emit CO2, like, for example, cement and waste power, and CO2 from such processes needs to be captured and stored. What we have learned from the Northern Lights project so far is when we're creating a new service where no demand exists yet, it is important to work on a full value chain. The Norwegian authorities have had the architect role in the Longship project by supporting both the capture sites and the transport and storage of the captured CO2. One has no value without the other. The project has been engaged with 50 to 60 customers on the continent, which are interested in storing their CO2 in Northern Lights. As the alternative is paying ETS cost and additional emission cost, and that is becoming more expensive. So CCS and Northern Lights are becoming all the more competitive. Then let me move to Humber. In the UK, Equinor is engaged in three main projects in the northeast of England. One is in the Humber, the Zero Carbon Humber Partnership. And then in Teesside, the Net Zero Teesside project. And a third one, working on the offshore transport and storage infrastructure, which will be shared by the Humber and Teesside industrial clusters. UK is a good place to be demonstrating hydrogen and CCS for various reasons. First, UK has by law committed to net zero carbon by 2050 and have an ambition to creating the world's first net zero industrial cluster by 2050. And to meet these ambitious targets, several funding programs are put in place. The last reason is that UK acknowledge that both blue and green hydrogen is required to meet their climate ambitions. The Humber and the Endurance CO2 storage projects are the first steps in creating the world's first net zero industrial cluster by 2040. The Zero Carbon Humber initiative centers around two elements. The first being the Equinor-led Hydrogen to Humber Salten, which we call H2H Salten. This is a hydrogen project at the Salten Chemical Park. H2H Salten will be the largest plant of its kind in the world to convert natural gas to hydrogen, combining a 600 megawatt autothermal reformer with carbon capture. It will enable industrial customers in Salten to fully switch over to hydrogen, and the power plant in the Salten to move to a 30% hydrogen to natural gas blend. From first production, H2H Salten will reduce its industrial emissions by nearly 900,000 tonnes per year. The second element is the hydrogen and CO2 pipeline network, which will be developed by National Grid Ventures. That aims to link H2H Salten to other industrial sites in the Humber region, enabling them, in turn, to fuel switch to hydrogen or capture their emissions. H2H Salten can expand to serve other industrial users across Humber, which employs 55,000 people in the manufacturing sector alone. Recently, we announced the cooperation also with our long-term partner and customer, SSE, on developing two power stations in Keadby within the Humber area, one CCGT with post-combustion CCS, and one station that will be fueled by hydrogen reformed from natural gas. So now, let me illustrate why it is important to focus both on blue and green hydrogen. Western Europe currently consumes about 8,000 terawatt-hours power annually based on oil and gas. What does it take to eliminate CO2 emissions from this energy demand? Well, first, if we just assume that 50% of this can be solved by electrification, and that we will source that electrification from renewable electricity. This is a huge challenge. 4,000 terawatt-hour is equal to about 1,000 gigawatt of renewable capacity, which is the same as 250 Dogger Bank wind farm projects, which, when built, will be the world's biggest wind farm by a large margin, and it has taken 10 years to mature. So, what about the other half? Let's aim to solve this by producing clean hydrogen. And then remember, we already exhausted the renewable power potential. If this should be done by green hydrogen, it will require 150 new nuclear plants of the size of Hinkley Point to power the electrolyzers. And then we need to build 50,000 of the largest electrolyzers that we have seen today, they are 10 megawatt. The capacity in the world today to actually build these electrolyzers are about 100 a year. So capacity and technology will of course help, but this will take a very, very long time. If we then look at achieving this global goal by developing blue hydrogen, we first of all know that the natural gas source, base and supply system are in place because they use today. Then we need 500 reformers of 1 gigawatt each, which transform natural gas to hydrogen. About 100 of these are added or produced in the world every year. So also this route takes time, but it is nevertheless a much quicker route compared to the green hydrogen. So in my opinion, we should stop talking about green or blue hydrogen. Let's talk about clean hydrogen and work together to make the energy transition happen as soon as possible. We will need both green and blue, as much as possible of both, and as soon as possible. And then let me sum up. I think most will agree that the end game has to be clean and safe energy. Electrification of end use of energy is a key to reaching climate targets. However, to meet the 2050 targets, we also need all we can get of both green and blue hydrogen, plus all other clean energy sources, and as quickly as possible. Another important message is that green hydrogen alone does not have the muscle to lift the hydrogen economy or the infrastructure required to decarbonize towards 2050. Therefore, framework conditions are required that encourage the development of CCS and hydrogen. So please acknowledge the immensity of the transition. It has never been done before, and the costs and efforts are enormous. Thank you.
Thank you so much, Grete, for that very clear presentation with high ambitions on behalf of Equinor. I was just wondering, when at the end there you called for better framework conditions for producing hydrogen through CCS, I guess you're addressing the politician in that manner. But what kind of framework are you thinking of? Are we talking about funding schemes or regulations? Where are we? What do you want? Oh, I think you're muted, Grete. Let's check the sound. Try again.
Okay, thank you. First and most important, stable and known frame conditions are important for the industry to make these large investments in facilities meant to be operational for many decades. And secondly, in this initial phase of the industry, where there is neither supply or demand for the products, a full value chain needs to be developed to start on both the supply and demand side. As they both also need funding. So to your question, yes, this is to the politicians, but also to our future partners, and also yes, to both funding support and regulations, actually. We need both.
And it's interesting, as you were pointing out, it's always a challenge when you have a product that no one demands at the moment. So where to start? It's like the egg and the chicken discussion in many ways. But nevertheless, I can see that both you and Henrik, who gave his presentation before you, your main message is, let's not compete about, what kind of technology we need. We need the solution. We need the products. Is it difficult to convince the decision makers about this so that you can sort of start establishing this value chain? You were talking about the Humber project, which seems to be rather big. You've succeeded in the UK because there are laws and regulations, if I understood you correctly, that are sort of preparing the grounds to do that. Is that something you're missing elsewhere in the world or in the European markets?
I guess the reason why I chose to talk about Northern Lights in Norway and Humber in UK is because in Norway, the government helped us putting funding in both the capture site and the storage side. So they help both the chicken and egg kind of thing, so that we came together. Then in Humber and UK, because of these legislations and their very ambitious climate goals, they have put a funding mechanism. And also that they don't differentiate between blue and green hydrogen. That is the main reason why that is our top priority when it comes to hydrogen. We see elsewhere in Europe and also other countries, they focus on one of the solutions, and therefore we hope that they will actually learn from UK, and that we in our Humber project can make a showcase in a way, to show that this can be done very clean and safe and also cost efficient and timely.
Grete, we don't have that much time now, and there are a couple of things that I would like for you to talk about. We can leave that for the discussion, but there's just one quick question from the audience, and I'm not sure if you have a quick answer, but we'll try. You mentioned the increased need for reformers for developing blue hydrogen. What would be the need for storage capacity, and what is today's status on that?
Well, we would need storage capacity, and in particular, if we provide the blue hydrogen for power plants that are supposed to be up and running when the wind is not blowing or the sun is not there. So if this is backup for renewable capacity, we definitely need storage. As part of the agreement with SSE that I talked to, we're also looking into developing storage for hydrogen. So it is not there now, but it is on the drawing board, and it has to be detected and developed.
Very nice. Well, thank you so much so far, Grete. We'll have the pleasure of re-welcoming you into the panel discussion later on. So for now, we say thank you and see you later.